Hello and welcome to this satellite meteorology tutorial, a demonstration of the mosaic and time delta imagery in AWIPS. As we all know, imagery from polar orbiters is highly useful in Alaska. Polar orbiter imagery does not suffer the pixel broadening and parallax problems seen in imagery from geostationary satellites. But there is a drawback. There is an abrupt cutoff at the edge of each swath. What if our problem of the day in this case is a storm chewing up the YK Delta Bristol Bay area? You're on the wrong side of the cutoff line, and so you have no imagery. Well, the good news is that we can now stitch together several different polar orbiter passes, with the result that the imagery has a quasi-geostationary footprint, and you do not suffer these problems of pixel broadening and parallax. To find this miraculous imagery, go here to Satellite, then down to GINA's single channel products and Mosaics. We'll tear off that menu because we'll want to use it later. And to get the imagery, click on 11 micron long wave mosaic. And voila, the result is this mosaic, several polar orbiter swaths stitched together. The result is a quasi-geostationary footprint. But of course, now we have a new challenge. This mosaic is comprised of several individual swaths, all arriving in AWIPS at different times. How do we know how old the imagery is in any specific region of this mosaic? Well, there's a solution to that challenge as well, and that is the time delta. Time delta isn't actually a satellite image, but it can be displayed in D2D and combined with a mosaic. So we leave the mosaic on the screen and go over here to our menu and click the time delta. Now we have combined these two images, and you can see that we have these solid colors overlaid on the exact footprint of the mosaic. And if you turn on the sampling, get some good information. For instance, up here, that pixel has a temperature of minus 13.5 Celsius, and what's that 0.4 H up there? Well, that means this pixel is 0.4 hours old, not quite a half hour old, relative to the valid time of this mosaic. You can see in the lower right corner, 1950 Zulu is the valid time of the mosaic, so these pixels up here in the northern part of this image are all maybe 25 minutes older than 1950 Zulu. So that's how you interpret that. Also note the color bar up here. That's the number of hours old that different colors correspond to. So by the time you get down here into the red, you're almost 3 hours old, which is exactly what it should be. And out here, this is ancient history, 11, 12, 15, 16 hours old. We're into the green and blue neighborhood. And you can see the general pattern here is that the newer swaths will tend to be at the center of the image, and then the older information is out around the periphery. That tends to be the way things work. Now, we don't really need to look at these colors, so to deactivate that, we can simply go here. Click on the label down in the lower right corner, and you've deactivated the visual part of the time delta, but the data is still in there. And see, if we leave the sampling on, the time delta appears 0.4 hours old, or down here 0.9 hours old, and you also get the temperature information. The value of the mosaics really shines when we loop the images in time. So let's do that and let it shine. And there we go. Again, thanks to Alaska's high latitude, the refresh rate of polar orbiter passes is comparatively prompt, especially over northern Alaska. This resulting loop here is a little bit jumpy, but it is analogous to loops of geostationary imagery. And speaking of comparing and contrasting this mosaic to imagery from a geobird, let's zoom in over the North Slope and the Arctic Ocean. So there we go. And AWIPS takes a little bit of time to catch up and react to the fine scale resolution. And that's the point here, is the spatial resolution. Note where we are. We're over the Arctic Ocean here, well above the Arctic Circle, and the spatial resolution is still sharp despite that high latitude. This is the beauty of these mosaics. Out in the broad view, they allow for a synoptic scale overview, but when you zoom in, you get the fine scale details. So from the synoptic to the local, mosaics do it all. So to summarize, mosaics mitigate the problem of hard edges seen in single polar orbiter imagery passes by stitching several passes together into one image. The newest pass is always on top. Adding the time delta and activating mouse sampling reveals the age of each pixel in any region of the mosaic. Looping provides a quasi-geostationary overview when zoomed out, and then zooming in reveals the sharp details that are harder to find in geostationary imagery. That concludes today's lesson. Hopefully you find these mosaics helpful. If you have any questions about these mosaics or any satellite products coming from GINA here at the University of Alaska, please send an email to satellite@gina.alaska.edu. Thank you for your time and happy forecasting.